Hi guys, I'm basically just continuing from what I'm saying. I was saying in the last video. I'm saying that I said that one of the methods was super interesting, and you see what we've done here. This function was given as y is equal to 2x plus y plus 2. So it was given as y is equal to 2x plus 2. This function was given as y is equal to minus 2x plus 4. Because we realize that we both have y's in our function, what we just did is that we equated them, right? And we solve. And therefore, this idea, we use it all the time when we deal with this function, right? We use it all the time. And basically when we solve for things like intersection, which is what we have here, intersection, we use this method called where we have to equate, if you remember let me just take you back to my methods. So I said this was interesting. I said it was interesting because we use it in solving the problems that are here, the problems that I just dealt with them. Okay, I'll end this video at this point. I just wanted to finish that. So I'll start doing examples now. Oh, maybe no. Maybe no. So yeah, we use this method when we're dealing with these problems, right? But where would you find this problem in your question paper? So I've basically took a particular paper. It's a past paper. It's from an exemplar. Let me just make sure that okay, I can't get myself out of this. But anyway, this is from an exemplar. You can see it's from the Department of Education, and it's a grade 10 test, and it's paper 1, right? So when we've done functions, I expect you to be able to do this, and it would be nice if you would go back to this video and be like, let's see what I can do here. Anyway, at some point they are asking, so they are giving you, maybe let me just start there. They're giving you f of x as a hyperbola over there. They're giving you g of x as a straight line. And the first question is asking you to sketch these two graphs in the same set of axes. The second one, it asks you to write the equations of the asymptotes. The third question is asking you to write the domain. Interestingly, the fourth question is saying solve for x when these functions are equal, right? They want to know what's the value of x at which these functions are equal. That's literally doing simultaneous equations. Maybe they didn't want the y, but you can find the x, right? So when they say solve for x, if these functions are equal, you're just going to say g of x is equal to, f of x is equal to g of x, and basically you would just substitute the equation here like that, and then you will substitute the other one, and you'll basically solve for x. What I want you to understand is that at that point, it's just like these two graphs, and when you equated those functions, when you said f of x is equal to g of x, it was like you are saying y is equal to y, because remember, you saying y could be given as f of x, right? And this other y could be given as g of x. We give f of x and g of x because we don't want to say y. If I say y, sometimes you might actually, in this case, you don't know what function I'm referring to. But if I say f of x, you know I'm referring to the green function. If I say g of x, you know I'm referring to the red function. So if I asked you where these two graphs intersect or meet, you would have we did that. You say y is equal to y, and that stems from the mere fact that where they meet, they share the y value. So you can just say that those are equal, right? But I want you to notice that question was saying solve for where g of x and f of x are equal. So what you were basically doing, you were finding only the value of x at which these two functions were intersecting, right? They can say find the intersection. When they say find the intersection, it basically means that you have to go on and also find y, right? In our question, we didn't find y. I'm gonna go this into detail, but I'm just warming you up and giving you a broader idea of why we are doing this, right? Remember also we had this problem and you can solve that, right? So okay, in the next video I'll take you through different ways of solving simultaneous equations, right? I'll see you in the next video, guys. Bye.